Every analog designer's nightmare would be to deal with noise in his circuit. When it comes to switching circuits or audio amplifiers or frequency signal circuits, there's a very good chance for the circuit to be affected by noise signals. Out of the many ways to remove noise from a circuit, the most used one is called the filter circuit. As the name suggests, this circuit will filter out the unwanted signals, which is the noise, from the actual signal. There are many types of filter circuit, but the most commonly used and efficient one is the bandpass filter, which can be easily constructed using a pair of resistor and capacitors. So, in this tutorial, we will learn about this bandpass filter, the theory behind it, and how it can be used in practical circuits. We can say that a bandpass filter is a combination of both low-pass filter and a high-pass filter. The name of the filter itself indicates that it allows only a certain band of frequencies and blocks all the remaining frequencies. In audio applications, sometimes it is necessary to pass only a certain range of frequencies. This frequency range do not start at 0 Hz or end at very high frequency, but these frequencies are within a certain range, either wide or narrow. These bands or frequencies are commonly termed as bandwidth. A bandpass filter can be obtained by cascading both high and low-pass filters. It has a huge application in audio amplifier circuits, as I mentioned, where the speaker has to play only the desired set of frequencies and ignore the rest. There are two types of bandpass filters. If the circuit involves some kind of external source of power, like transistors, operation amplifiers, etc., then the circuit is called as active bandpass filter. And if the circuit does not involve any active components and consists only passive components like resistor, capacitor, and inductor, then the circuit is called as passive bandpass filter. As told earlier, we will discuss the passive bandpass filter, which is constructed using resistors and capacitors. It is a combination of a high-pass filter and low-pass filter. The first half of the circuit is a high-pass filter, which filters the low frequencies and allows only the frequency that is higher than the set high cutoff frequency. The value of this high cutoff frequency can be calculated using this formula here. The second half of the circuit is the low-pass filter circuit, which filters the high frequencies and allows only the frequency that is lower than the set low cutoff frequency. The value of low cutoff frequency can be calculated using this formula here. By adjusting the cutoff frequencies of the high-pass and low-pass filters, we can obtain the appropriate width of the passband for the bandpass filter. Since this filter passes a band of frequencies, this filter contains two cutoff frequencies, right? Lower cutoff frequency and higher cutoff frequency. As a result, the range of the frequencies which are passed through the filter is called as bandwidth of the filter. In general, the bandwidth of the circuit can be calculated by doing the difference between the higher cutoff frequency and the lower cutoff frequency. The bandpass filter will pass the frequencies higher than the cutoff frequency of the low-pass filter and lower than the cutoff frequency of the high-pass filter.